Hi, I'm Steve Sugden, Chief Technical Officer for the LINQ brand of height safety equipment. When we developed the LINQ range of fall arrest systems, a minimum design standard was for compliance to the BSI benchmark compliant EN and ASNZ suite of height safety products. Further to this, we also concentrated on suspension trauma mitigation. However, our research led to two major concerns which are all related to moment of impact. Firstly, the rear or dorsal D setup. So many harnesses have a floating D setup where the D is held in place by a mere piece of plastic. The danger is that at the moment of impact there is a significant risk that the D will break through the plastic holder due to the shock loading involved. The plastic keeper generally having less than 80 to 160 kilograms of tensile strength, resulting in the D and associated hardware sliding all the way up the webbing and smashing the back of the worker's neck. This is a major reason fallen workers are rendered unconscious even before they're rescued. As you can see, we have now completed a drop test on a competitor harness. Now look where the D has moved. If you look here, you can see where the original manufacturer had marked in chalk where the D was supposed to have been positioned for its workers. And now after the fall, you can see how much it's migrated. In this instance, it looks like it's migrated 90 millimeters. 90 millimeters is a significant migration, particularly when you add to that, there would probably be a snap hook or a carabiner connecting the lanyard to the back D. And if you can imagine where the person's back of the head would be, so we have a guaranteed workplace injury statistic. Here we have the LINQ setup where the shoulder straps go through the cross member of the D, the top cross member, and on the bottom cross member we have the other strap coming through. There's no floating D. We've taken the liberty of putting a mark here. We're now going to drop this and see how much this D is going to migrate. And here we have the LINQ harness that has now completed its drop test. You'll notice that the D in relation to where we had marked it has not moved at all. The closed loop system of the LINQ harness proving to be totally safe. The second issue, and just as concerning, relates to harnesses with so-called centered front fall arrest attachment point. From research, we found that the vast majority of harnesses that have a frontal D that is positioned to the left of center. This significantly increases the risk for facial or other injuries. The frontal D and the chest buckle at the moment of impact will move upwards and smash me in the face, and at the same time twist and hit me in the sternum. Guaranteed to render me to be a workplace injury statistic. And this is the dummy as it is after a frontal attachment fall. Because the D is not centered, you can see that the dummy is now resting at an angle. So at the moment of impact, it's going to cause a vectoral force which will create all types of problems, particularly underneath the rib cage. And if this piece of webbing migrates underneath the rib cage, you could bruise a rib, crack a rib, break a rib, puncture a lung, and we've got a serious problem. Extra length belay loops for comfort and safety. They're angled to go under my buttock. So in the moment of impact, which I'll show in slow motion, I won't get hit in the face with the frontal bucket, and illustrates how it pulls me away straight, rested, seated, comfortable. And this is why the LINQ harness is terrific for this type of frontal attachment application. So at the moment of impact, safety design factors including padding behind the buckles of the LINQ harness, which eliminates bruising to the worker during the fall. Buckles are placed high in the thigh area and will not result in eye-watering moments if they're placed too low. At LINQ, we have our own buckles and webbing, so the design relationship between the two has been carefully considered to ensure correctly and easy-fitting harnesses. Both padding and retroreflectivity webbing is currently unique to the European and to the Australian market. Right, now correctly fitting a harness is critical to ensuring it can do the job it was designed for in the event of a fall. But if a harness is incorrectly fitted, the force distribution changes in the moment of impact, leading to increased injuries such as head or facial injuries. Correctly fitting means both ensuring it is the right size for the individual as well as ensuring it is worn and adjusted correctly. Often workers think they are wearing the harness correctly, when in fact they are not. A good harness should shepherd the worker into the correct fit if they have it wrong. It should be noted that LINQ harnesses achieve this exactly. The limited leg strapping guides the wearer into adjusting the shoulder webbing correctly first, and then ensuring the belay loops are connected underneath the buttocks in a position where the fall arrest hardware presents no danger whatsoever. Now we've survived the fall, thank goodness. What's next? The tourniquet effect on my harness is causing blood to pool in my legs as venous return is inhibited. My heart is beating faster, my diastolic and systolic rates are plummeting as blood volume around my vital organs reduces. Other symptoms include sweating, tingling in my arms, dizziness, pins and needles, nausea, heart palpitations, and convulsion followed by fainting. So how do we prevent this? The LINQ suspension trauma strap eliminates the tourniquet effect. So all the pressure in my femoral artery is removed, and it's easy to deploy and easy to adjust. They've been clinically proven and tested to prove how much it alleviates, and in fact I can happily hang here all day long. I have in fact hung for more than 2 hours in a laboratory during our medical trials. Lanyards are a critical component of the fall arrest system and can mean the difference between a severe injury at the moment of impact and walking away unharmed. European and Australian standards both state lanyards must limit peak stopping forces to 6 kilonewtons. The LINQ range of lanyards limits the peak forces to less than 4.8 kilonewtons, thereby significantly reducing forces on the body during the moment of impact. All LINQ fall arrest safety products have been painstakingly designed, painstakingly engineered to provide class-leading protection in the moment of impact and, of course, after it. LINQ's fall arrest systems are competitively priced and are built upon Paramount Safety's ethos of providing only the highest quality at a fair price.